So here's a quick review of what we did last time. So we're talking about signaling energy and signaling power. And if you recall, we said, KG, energy, when we say energy, as far as this course is concerned, we do not necessarily mean the physical energy in joules, but rather it's a quantitative metric, an abstract metric that captures the strength in the signal or the size of the signal. Signal kitna bada hai, kitna chota hai. Um, and that's energy. What is the definition of the energy? The equation 1 that you see on your screen. This is the definition of energy that we're going to use throughout the course. So if you give a signal which is a function of time t, varies as a function of time t from minus infinity to plus infinity, all you're going to do, you're going to take the absolute value of the signal, square it, right, and then integrate it from minus infinity to infinity. So that's the energy in that signal. And if you want to compute the power in that signal, the power is really energy per time, right? So you would normalize by the time interval, and that's definition number 2. Okay, you'll work in the limits, t going to infinity, 1 upon 2t, and then integral from minus t to plus t of x of t absolute squared. Okay, and then I think last night I added these notes. You're welcome to read through them. Just some examples about the abstraction. Why is it useful? Why is it not useful? Okay. Um, and then we did an example. All right. So we talked about something called energy signals, the definition of an energy signal. So energy signals are defined as those signals, as you see on your screen, which have finite energy, right? So the energy is between 0 and infinity. It does not approach to infinity. If it's finite, then we say that signal is an energy signal. And if the energy is finite over an infinite time interval, that automatically means that the power of this interval is going to be 0, because it's a finite number divided by an infinite number that's always 0. So therefore, an energy signal has a finite energy and 0 power. On the other hand, we define something called power signals, and those power signals are those signals that have finite and non-zero power, right? And that the only way that could happen is if the energy in that signal is infinite, okay? So this leads us to the conclusion, I mean, from these statements 1 and 2, that if you have an energy signal, its power is going to be 0, and therefore it cannot be a power signal, right? And on the other hand, if there's a power signal, that power signal will have an infinite energy, and therefore it cannot be an energy signal. So a signal can never be simultaneously an energy signal or a power signal. Okay, so that's a conclusion that we made. What I'm gonna do now is just gonna give you some examples, actually a couple of examples, to illustrate these two signal to illustrate energy signals. And so I'm gonna give you an example of power signal, and I'm gonna give you an example of an energy signal. Okay, so here's example 2, right? And the reason why it's example 2 is because example 1 is what we did last time, right? So this is an exponential which is decaying, right? And we computed the energy in that. The energy turned out to be half, and the power turned out to be 0. So what kind of signal is this signal that you see on your screen? I mean, is this an energy signal or a power signal? Right?
Energy signal.
So it's an energy signal, right? Because the energy is finite and the power is 0. So therefore, this is an energy signal. Okay. Let me give you another example of an energy signal, and that is, instead of giving you a mathematical form, let me just plot it out for you. So you're given a signal x of t, which looks something like this. So you have the time axis here, right? So this is t, and this of course is the origin and the intersection, and the signal looks something like this, right? So it's 0 for all time less than 0. It turns on at time t equals 0. It goes all the way up to 2, an amplitude of 2, and stays on at amplitude of 2 till 1 second, and then goes to a negative 2, and then stays on for another second, and then goes back to 0. And this is time 2 seconds, and this is time 1 second. Okay, so if this is a signal that's given to you, so let's say this is x of t, and I ask you to determine what the energy in this signal is, how would you do that? So E infinity kya hoga? By definition, remember, E infinity is an integral from minus infinity to plus infinity, the absolute value of x of t squared and area under the curve of that. I mean, what is this equal to? I mean, you can do this without really doing the integration. Okay, Ji Abdullah, you have the right answer, but can you explain to me how you got it?
ओके सर, तो जब हम इसको एब्सोल्यूट वैल्यू करेंगे तो इंटायर 0 से लेके 2 तक 2 ही रहेगी उसकी वैल्यू। उसको जब हम स्क्वायर करेंगे तो वो 4 आ जाएगा, और एरिया करेंगे तो 4 into 2 रेक्टेंगल का एरिया का फॉर्मूला तो 8 आ जाएगा।
Excellent, right? So you don't really need to compute the integral, or the integral is as a simple area under the curve, which I can find out. So this is, as Abdullah said, this, what I'm plotting here is what? So this is 0, this is 2, and what I'm plotting is x of t absolute squared, and the height is 4, right? And area on the curve is equal to 8, and therefore this is nothing but 8, right? What about the power? That should, of course, be equal to 0, right? So this is an example of a very, very simple example of an energy signal, okay? Let me do another example. And of course, this example is going to be that of a power signal. So here's what the signal looks like. I mean, once again, it's a graphical representation that I'm going to give you. So this is time t. So this is the axis. Okay. This is what the signal is, and the signal is equal to -2 for all time t is less than 0. At time t equals 0, there's a discontinuity, and it goes to +2 and goes all the way up to infinity, right? So this is +2 and this is -2 as far as the amplitudes are concerned, okay? Right, so there's, okay. So right, so this is x of t, okay? How do you compute the energy now? So there's some comment about hearing. I mean, can you hear me fine? Is it somebody else? मेरी आवाज सही आ रही है?
Yes, sir.
Yes,
Okay.
sir.
All right, fine. Right, so this is x of t. This stays at equal to -2. And if I were to write this mathematically, I mean, can somebody help me here? I mean, if I were to write this mathematically and what this signal is, how would I write this? So who's going to help me here? Piecewise, okay. Somebody else? Anyone? Otherwise, I'm going to start picking on people. Right, Asmir, chale. Asmir, without really saying anything about the signum function, I mean, we don't know the signum function yet. ठीक है, तो इसको piecewise किसी तरीके से describe कर सकते हैं, Asmir?
बिल्कुल. For t greater than 0, it will be +2, and
Yeah.
for t less than 0, it will be -2.
Right, nice. Okay, so this is equal to +2 for all values of time greater than 0, and is equal to -2 for all values of time which is less than 0. Okay, so this is what the mathematical representation of the signal may be. And if I were to give you one or the other, graphical or this mathematical, you should go from one to the other. Okay, acha. Ab you need to compute the energy. I mean, any ideas of what the energy is going to be? So what is the energy? What is the energy in this signal? Manur, what do you think is the energy in the signal?
Sir, I'm not sure. Like,
Okay.
I think it's an integral from
right, let me write down the definition, right?
Yes, x of t dot
absolute squared. So this the step function that you see, I mean, just stays -2 and then goes to +2. If you square this, what are you going to get? You're going to get something which is equal to 4 for all time from -infinity to +infinity. Okay? If you integrate that, if you find the area under the curve, what are you going to get? I mean, what is the area under the curve of a constant signal which stays constant from -infinity to +infinity? And the answers are there in the chat box.
Sir, zero नहीं होगा?
Why 0, Manu? So you're squaring, right? So you need
सर
to
लेकिन अगर हम नोटिस करें जो ऊपर वाला एरिया है वो कैंसिल नहीं, ओ नहीं, ठीक है,
square, right? So you're squaring first. If you square it, so then the negative also becomes positive. Okay?
ठीक है,
Right? So this
Thank you,
is
sir.
nothing but integral from -infinity to +infinity, and this is just 4. And this is of course infinity. So the energy is infinite, right? So this cannot be an energy signal, right? What I want to do next is compute the power, and the definition of power is what is you work in the limits, limit t going to infinity 1 upon 2t, and this integral goes from -t to +t x of t absolute squared dt, right? And what is this equal to? So this is limit t going to infinity 1 upon 2t integral from -infinity to +infinity. What is the absolute value of x squared? Since x is either +2 or -2, if you square it, it will always be equal to 4. Okay? It will always be equal to 4 regardless of what time you're talking about, right? So this is always going to be equal to 4. This is just 4. Oh, actually, sorry, this is not -infinity. This is -t to +t. Okay? What is this integral equal to then? In the limit, so this is limit t going to infinity 1 upon 2 times t. This is 4 times 2 times t, and this is equal to 4, right? So the power in this signal is finite and is equal to 4, right? So therefore, this is a power signal, right? This is a power signal. The energy is infinite. Okay, so this was an example, a simple example of a power signal, and we may be coming across other examples as well. I mean, there's some problems in the homework as well. You're required to compute the energy and power and determine whether they're energy signals or power signals.
Excuse me, sir.
G Zen.
सर यहाँ पर हम लोग 2 इन्फिनिटी या 4 इन्फिनिटी तो कोई चीज नहीं होती ना, कि 4 टाइम्स इन्फिनिटी या 2 टाइम्स इन्फिनिटी, मतलब इन्फिनिटी तो इन्फिनिटी है ना, लाइक ऊपर जो हमने एक्सप्रेशन इवैल्यूएट किया है,
क्या
अगर हम उसको करते हैं 4t करते हैं फिर इन्फिनिटी माइनस इन्फिनिटी हो जाएगा, तो वो
नहीं, ये नहीं होगा. No, Zen, ऐसा नहीं होगा. I mean, you evaluate it first and then compute the limits and then take the limit. ठीक है? So limits may, I mean, so that's why it's important to see KG how things grow in that limit. And what we see is that the numerator grows and the denominator grows as well, but they both of them grow linearly, and that's why they cancel out.
Yes, sir. Yes.
Okay, अगर ऊपर वाली चीज squared होती है, so that means the numerator would be growing with the squared rate, and that's much faster than the denominator. And then in that case, that limit is gonna evaluate to infinity. Okay, but not so here. I mean, because the numerator is linear, the denominator is linear as well. Okay, in t. Is that clear?
So how did you? So can you explain again how you got 4 from xt squared?
Okay, because x of t is either equal to +2 or is equal to -2, right?
Yes, sir.
And what happens when you square that? What happens when you square -2?
4.
4, right? So let me show this here. If given this x of t curve, I ask you to determine x of t absolute squared. What would that be?
It'll be a straight line on 4.
It will be a straight line, excellent. Where? What would that magnitude
be?
Of 4, right? So this is x of t squared, which is equal to 4 throughout. And that's what I'm integrating.
All right, understood.
Is that clear? ठीक है मुनीम?
Yes, sir, understood.
All right, nice. Okay, so this was an example of a power signal. Now here's a question for you. So we talked about energy signals, and we say the energy signals cannot be power signals, right? And there's a power signals, and we say power signals cannot be energy signals. Does that mean that a signal is either an energy signal or a power signal? And the answer to that is no. Okay, because there may be some signals out there which may neither be energy signals nor power signals. Okay, so some signals may neither be energy signals nor power signals. Okay, and one example I can give you is x of t equals t, right? It's a ramp function. Okay, you can try to compute the energy. The energy is of course going to be infinite. You can try to compute the power as well. The power is going to be infinite as well. Okay, and therefore this signal is neither an energy signal nor a power signal, right? So these are not exhaustive classes. Okay, so there's maybe some signals which are neither energy nor power. Okay, G is N. Do you have a question?
सर जो हम लोग ग्राफ ड्रॉ करते हैं तो उस ग्राफ में सर अगर हमारे पास कोई भी ग्राफ होगा सर जो हम उसका एरिया अंडर द ग्राफ लेते हैं तो सर बेसिकली जब हम लोग कहते हैं कि इन्फिनिट एनर्जी है इसका मतलब ये है कि हम लोग ये कहते हैं कि जो उसका एरिया अंडर द ग्राफ है वो इन्फिनिट है बिकॉज वी स्क्वायर इट तो सर वो तो फिर कोई ऐसा फंक्शन होगा सर जिसकी एनर्जी इन्फिनिट ना हो लाइक जिसकी
Then what was example 2?
सर मगर इसमें तो जब हम इसका भी स्क्वायर करेंगे तो फिर
Yeah.
अच्छा हाँ ठीक है वो एंड पे 0 हो जाती है ओके सर हाँ सॉरी सर
Exactly. ठीक है, so that's a good point. So अगर किसी सिग्नल की एनर्जी फाइनाइट है, right? I mean, what are the conditions necessary for that happening, right? One of the necessary conditions may be that it would be of finite duration and it's going to be 0 throughout otherwise. ठीक है, थोड़ी सी duration इसमें on होता है. मेरे ख्याल में आपने पिछली बार क्वेश्चन पूछा था, and then it returns to 0 and it stays 0. ठीक है, that is one condition. ठीक है, but there may be other signals which may not go to 0 but decay to 0. So they have to decay to 0. Okay, and for the energy to be finite, and this was an example for that. ये वाला e raised to the minus t.
सर फिर जो सॉरी टू बट सर जो एक्सपोनेंशियल फंक्शंस होंगे उसके बारे में क्या कहेंगे सर हम लोग?
That's exactly what I'm saying right now, right? So
सर जो एक्सपोनेंशियल फंक्शंस होते हैं वो तो इन्फिनिटी पे जाके अज्यूम करते हैं.
So then this is exactly what I'm saying once again. The thing that you see on your screen is an exponential function.
So वो नेट लैग कर रहा है थोड़ा सा. I'm sorry for that.
Okay. So e raised to the minus t, right? So this is an example we did. This is an e raised to the minus t. That means it stays on all the way up to plus infinity. But it decays, and it decays exponentially. Okay? So if you compute the energy for this, like we did last time, this turns out to be finite as well, even though it's of infinite duration. Okay, no problems then, as long as it's clear now. Okay, so it can be of infinite duration, but because it decays exponentially, the energy is finite in this case as well. Okay, now there was another question I think by Azmir and said, is this power in watts? Right, so what do you think, Azmir? What can somebody else answer this question? Because that's what I started out with in the first place, this class. It is not. Why is it not, Hassan?
Because we didn't decide on the units. This was not supposed to be a physical power or energy.
Exactly. This is not supposed to be a physical power. It's an abstract power. It's an abstract mathematical construct. Okay? Which may or may not be related to power, the physical power. Okay? But for isliye hamjhe isko. So the question was, is this power in watts? The answer is no. It's not in watts because it's a mathematical quantity. It's an abstract quantity, which may not be the physical power. Right? So I would urge you to further and to seek answer to this, I mean, I wrote some notes here as well, and please go through them, especially this one, an important note about the abstraction. Okay? All right. So I'm going to move ahead to the next topic now, and that is with, what is that topic? This is transformations of signals on the time axis. Okay? So the first transformation I'm going to talk about is time shifting. And time shifting, for example, could be that there's a signal given and you delay that signal. And a primary example for this could be, for example, radar signal processing में क्या होता है? उसमें you transmit a certain waveform, right, into the air, into the environment, right? And then if there's a signal, if there's an object of interest which reflects that signal, and at the receiver, you would obtain the transmitted waveform, but after a delay. And actually, what you do is you compute the delays, or delay ki bina pe, you try to decide कि जी object कितना दूर है, right? So that's very, very roughly speaking, could be a way or the principle behind how radars work. Okay. But what we're trying to do, going to do here is, to delay hai, how do you mathematically describe a signal delay, right? That's what we're going to talk about. So let's me start with an example here, and say that there's a signal which is called x of t, and this is what the signal looks like. So this is x of t. The x-axis is, of course, the time. So this is time. And this is what the signal looks like. This is signal यहाँ से यहाँ पे जाता है और फिर something like this. Okay. Let me change this a bit. Let's go simply कर लेते हैं. Right. So this is what the signal looks like, right? It is equal to 0 for all time t is less than 0. Okay. And this time is 1 second. This time is 2 seconds, and the height is 1. Okay. Now let me give you another signal here, which is, let's say, y of t, and this is what y of t looks like. So this is the time axis, right? This is what the signal y of t is, and y of t is a delayed version of x, right? So I mean, whatever x was, I mean, you delay that by, let's say, 1 second, right? Delay that by 1, and what you get is something which looks like this. All right. Okay, this is what time t is. All right. So if it's delayed by 1 second, that means it starts, instead of starting at 0 seconds, it starts at 1 second. Okay? And instead of ending at 2 seconds, it ends at 3 seconds. So that's what a delay by 1 second means. Okay? And this point here where the decay starts, this is going to be 2 seconds. Okay? So this is y of t. Right? Now, my question for you here is, how do we relate, mathematically speaking, how do we relate y of t and x of t together? I mean, if I want to write y as a function of x somehow, where there's a transformation inside the independent variable somehow, I mean, what would that be? Can somebody try to give me that answer? G Zen.
Sir, x of t minus 1 is equal to y of t.
All right, nice. So we say, okay, yeah, x of t, or actually y of t, is equal to x of t minus 1. Why do you say that, Zen? I mean, can you explain your reasoning?
Sir, we have actually studied this in circuits. So, sir, उसमें भी हम लोग time shifting में यही करते हैं. Like if you subtract -1 from the अंदर वाली side ना सर, तो वो 1 second आगे shift हो जाता है.
क्यों हो जाता है? I mean, so okay, that's what I'm asking. So when you try to explain what you know to others, I mean, that would improve your understanding as well. So if you can put this in words, I mean, why is y of t equals x of t minus 1? Let's say if you were to explain this to a sophomore, you're actually sophomore, selling a freshman. किस तरह करेंगे explain?
सर वैसे तो जो बेसिक वो है उसमें हम लोग ये कह रहे हैं कि जो y of t है that starts 1 second after x of t.
Yeah.
Sorry, like जब हमने x of t शुरू किया है तो जो y of t है वो उससे 1 सेकंड बाद शुरू हो रहा है.
Okay.
तो अगर हम लोग x of t से -1 करते हैं तो we are assuming कि वो 1 सेकंड पहले वाला शब्द शो करे, तो इसलिए वो दोनों ग्राफ सेम हो जाते हैं.
Okay, good.
If that makes sense.
Right. Excellent. Asmir, you wanted to say something as well.
What I wanted to say was very similar, just that k y of t is the delayed signal,
Yeah.
and x of t it's -1. So what happened 1 second ago, -1 will happen in y of t. So that's why it's x of t.
Excellent, Asmir. I mean, that's what I would that's how I would put it as well. But before I do that, let me go to Musa. Joe, just because you're not taking circuits too,
Yes,
I just
sir.
want to get a feel of, I mean, what your thoughts are on this.
So actually very similar as well, that just like this is basically like right shifting, and whatever is happening in circuit X or in the function X, that thing is happening in the function Y, but just 1 second later with a delayed, which is why we're taking t-1.
Excellent. So that's exactly how I'd put it. I mean, just what Zain said, what Azmir said, and Musa said, and all of the others, I'm sure, thinking exactly the same thing. And the way I would put this is the following. This is a delay, and I mean, how does Y and X compare? The way they compare is the following, which is whatever happens at Y at time t happened at X at time t-1, right? Another way to put this is the value that Y takes at time t is the value that X took at time t-1. And that's why it's a delay. Okay, so let me phrase this again. So say this again. The value that Y takes at any time t is the value that X took at time t-1. And that's why it's a delay. Okay? So let me write this here. So the value that Y takes at time t is the value that X took at time t-1, and that's why it's a delay, right? And another way for me, by the way, for me to write this, what could have been that Y of t plus 1 is equal to X of t. I mean, does that make sense? Because they're exactly the same, both of them. Right? Does that make sense then? And what you're saying is that whatever the value that Y takes at time t plus 1, X took at time t. ये भी delay है, ये भी past है.
Yes, sir. This short.
Right? So they're both the same. Right? So this is a delaying operation. Right? So you delay something by one second. In general, if whatever X of t was that I gave you up above, and what would Y of t minus t naught be? Okay? So in general, if let's say this is X of t that starts, let's say, at time t1, takes on some form, goes back, turns off, and this is time t1, this is time t2. So if I were to sketch Y of t, which is equal to X of t minus t naught, what would that be? What would that be?
So you just draw another graph जिसमें t1 जो है वो t0 से शुरू हो रहा है और t2 is like t2 is t0 plus t जो भी होगा आगे.
Okay, but t1 से तो नहीं start होना चाहिए फिर, right? So this would be something like this. Ji Musa?
So I just wanted to say that maybe ऐसा होगा कि t1 plus t0 से start होगा, मतलब the starting, and then it will end at t2 plus t0.
Good, right? So this would be t1 plus T naught, starting at T1 plus T naught, and this would be T2 plus T naught, and this would be a delay. And of course, this would have been where T1 was. So that T1 plus T naught turns out to be greater than T1. And that automatically means that T naught ki kya property hogi? I mean, if this is the graph that you're seeing here, if T1 is on the left and T1 plus T naught is on the right, okay, that's a delay, of course. That's a delay. If that's a delay, what condition should T naught satisfy? I mean, what condition should T naught satisfy? T naught is, okay, Ji Talha?
T naught should be greater than T1. Yeah, T1.
Then any principle. So Piston socheng Talha, you're almost there. If T1 is on the left and T1 plus T naught is on the right, and then T1 plus T naught, T1 se bada hai, so T naught must be?
So it must be positive.
Must be positive, right? If T1 plus T naught is greater than T1, then T naught must be positive, right? So the condition here is, for the sketch that you see, is that T naught must be greater than 0, right? So this in general is a delay. So in general, so delay in general is the following. Y of t equals x of t minus t naught for t naught is greater than 0. So this is important. T naught has to be greater than 0 for this operation to be a delay operation. Okay? Can I say something about advance? So if I want to pull this signal back, and उसको मैं delay करने के बजाय, what I want is that the signal to be pushed back, it should be advanced. In other words, whatever happened in X at time T should happen in Y at time T minus 1, should have happened in the past, not in the future. Okay? So since the Y has to be pulled back. So what would, how would that work then?
T plus 1. T plus 1.
Plus 1. Okay. Excellent. Muhammad, somebody else raised their hand as well.
Yes, sir. Yes, sir. Sir, minus की जगह plus कर देंगे. X t plus t naught.
Right. Excellent. So Y of t should be equal to X of t plus t naught. For t naught is still greater than 0.
Yes, sir.
Okay. Acha. Can I bind these two together into a single framework and just call it a time shift? Here's how I can do this. So time shifting in general so combining actually, I mean this statement and this statement, I can combine both of them together into a single expression, and that is time shifting in general corresponds to the following: that Y of t is equal to X of t minus t naught, and that's just one expression that I'm looking at. However, this will correspond to a delay for what values of t naught? When t naught is greater than 0, right? And this will be an advance for t naught is less than 0. I can combine 1 and 2 into the single equation. Does that make sense? Does that make sense? Because when t naught is less than 0, minus t naught is positive in the first place. So, I mean, everything is consistent. Okay? So here's a boxed, if you will, conclusion. This is mathematically what time shifting is. Okay. Right. Any questions here before I go ahead? So this is the first transformation, which is the first transformation is time shifting, which could either be a delay or it could be an advance, but it's put into under the single framework, which is Y of t equals X of t minus t naught. If t naught is positive, that means y is a delayed version of x. If t naught is negative, we say that y is an advanced version of x. Okay, so that's it. All right. So here's a second transformation, which is, I think, is time reversal. All right. So let's say if there's a signal which is x of t and looks something like this. Okay, so this is time t and this is x of t. Oops. If I want to flip this around the y-axis, I mean, what mathematical operation do I do? So this is the flip version, right? So this is t, and this is y of t, and this y of t looks something like this. Right? Okay, Daniel, nice. Right? So if I y of t, how is y of t related to x of t? Because y of t is a flipped version of x. So y of t turns out to be equal to x of minus t. And once again, if to make sense of this, I mean, one of the ways to do it is to explain this is the following, which is you say, okay, the value that y takes at time t is actually the value that x takes for time minus t, and that's why it's a flip around. So therefore, y of 1 is actually x of minus 1, and y of minus 1 is x of plus 1, and that's why it's a flipping. Okay, that's why the curve just flips around the y-axis. So this is called a time reversal. Okay? Any questions here? I mean, this was pretty straightforward. And by the way, so I'm going to put up some audio clips on LMS as well after the class, perhaps in the evening, which is, okay, I'm not sure if you've, I mean, back in the 90s, I believe, I mean, there was this conspiracy theory, which was, Michael Jackson, there's the soundtracks that you play them backwards, then there's satanic messages embedded in those. I mean, but you have to play them backwards. Okay, anybody familiar with those conspiracy theories or just?
Yeah, I've heard of that one.
Yeah, well,
Yes, sir.
Freemasons or whatever, right? So, and actually, this is a task that we had freshmen do in their EE100 as well. So I embedded that not so satanic message inside of my own voice, and when you could hear it only when you played backwards. And I will probably upload that as well. So that embedded message there, and you can use MATLAB to do that. And perhaps that's a good exercise for you to do, right? So that flipping and playing audio backwards is this time reversal, right? So that's what time reversal does. Okay. So just a side note there, right? Then this is
सर पक्की बात है नहीं आते डीमंस
आप जो बिलीव करना चाहें कर लें यार so time scaling okay so that's a third transformation on the time axis that we're going to talk about. Okay, so for this let me start out with the signal x of t, right? So let's say there is a signal x of t. This is x of t. This is the time axis. And what the signal looks like is of this form. Right, so let me. Okay. So this is 2 seconds, this is 1 second, this is 0, of course, this is -1, and this is -2. Okay. So by the way, अगर मैं x of minus t compute करूँ, what would that look like? What would x of minus t be?
सर इस केस में तो सेम ही लगेगा वो.
It's the same ही लगेगा because it's symmetric around the y-axis, right? So if you flip it, I mean, it doesn't matter. This is exactly the same. इस की अगर ऑडियो सिग्नल आपको मिल जाए तो फिर flipping it is exactly. By the way, English language में there's a I forget what the name was. For some words you spell them backwards. They're the same. For example, dad, right?
Palindromes.
क्या कहते हैं sorry मुनीम? मुनीम ने बोला कुछ.
Palindromes.
Palindromes. Yeah, something. So I remember from my son's classes. Right. So let's say this is a signal which is y of t, and I'm going to give you two signals. And there's another signal which is z of t. And y of t is a compressed version by a factor of 2. So it's a compressed version of x. And how is it compressed? This is what is meant by compression. So this may not be to scale, but I'm going to put in the numbers here. So this is +1. This is half. जो कि 1 था वो half हो गया, जो 2 था वो 1 हो गया, and this is -half, and this is -1. But the heights are same. So let's say if this is 1 and this is 2, this height remains at 1. This height remains at 2. Right? Because this is y of t. Then z of t is the following. It's an expanded version of x. Right? So this is now 4, this is 2, this is -2, and this is -4, right? And this was t, right? So this is compression, of course. What we had done is, okay, the signal, whatever the signal was, you just compressed it, okay? Palindrome, right? Ji Musa, do you want to answer this palindrome, or you have another question?
No, sir. I had a question regarding this.
Ji, please go
So I
ahead.
just wanted to ask, is this compression or expansion only in the x direction, or can it also be vertically?
All right, that's a good question. Let me come back to you. Musa, just remind me when we're done here.
Okay.
Let's talk about this on the time axis, then talk about on the y-axis. Okay?
Okay.
अच्छा, अगर मैं नहीं बोलता तो फिर मुझे याद कराएगा. Right, so this is 1 and this is 2. Right. So y of t is a compression of x on the time axis, so that you've basically squeezed the signal down by a factor of 2. And z is a signal that has been expanded, has been pulled apart. X has been pulled apart by a factor of 2, and the signal that you get is z. Okay. The question then is, how is y related to x mathematically, and how is z related to x mathematically? Right, Ji Manu.
Sir, in y of t would be equal to xt divided by 2, and in z of t would be equal to x bracket t into 2.
Okay, so let me put these two options here, and we're going to see matching करनी है, right? So it's clearly, I mean, the two options that Manur gave us is either x of 2t or x of t by 2. The question is which is which? Okay. So Manur said that x of 2t is expansion. Is that what you're saying, right?
Yes, sir.
That's what you were saying. And this is this. That's what Manur. I mean, what is your line of reasoning for this, Manur? Can you?
Sir, because t की values expansion में by a factor of 2 increase कर रही है, and for the compression they're decreasing by a factor of 2.
Okay.
लेकिन now I'm reading the comments, अब मुझे opposite लग रहा है.
That's fine. I mean, it doesn't. कोई मसला नहीं है. I mean, so I mean, that's how we learn, right? So comments and other comments. Ibrahim, you raise your hand.
जी सर, मैं कह रहा था, आई थिंक शी इज राइट के जो काम x 1 सेकंड में करता है तो वो काम y हाफ सेकंड में कर लेता है. आई थिंक इस तरह अगर इसको कहना.
Okay. So both Manur and Ibrahim have the same answer. Let's go to the other side. Hafza, do you have a different answer, or you have the same answer?
No, sir, I also have the same answer कि the first graph that we made, हम उससे compare करके check कर रहे हैं कि वो increase किस factor से कर रहा है दोनों. So I also think it's the same. Yeah.
Okay, so Abdullah has the same answer, Hafsa has the same answer. Talha, do you have a different answer? Azmir has a different answer. So let me go to
Sir,
Talha first because he raised his hand earlier.
okay, sir, basically अगर x में 1 है, if t is 1,
Yeah.
on y it is 1 by 2, so t should be t divided by 2. It should not be 2t.
Okay,
So,
for expansion?
Sorry, I lost the track.
Okay, that's
X is equal to 1, and on y for compression it is 1 by 2, so
Yeah.
it should be t over 2.
Okay, Azmir?
Yeah, I say for compression, it should be x 2t.
Yeah.
Because what is happening on 2t will happen at t on y, so it will compress, and and the opposite for the expansion.
Okay, good. Thank you, Azmir. So the correct answer is what Azmir gave us. The correct answer is what Talha gave us, and I think there were some other correct answers on the chat window as well. Okay, and here's why. So this matching is actually not correct. This cross matching is not correct. Okay, good. Hassan, that's good as well, and I'm going to explain that. So this is the matching which is correct. So compression is indeed x of 2t, expansion is indeed y of t by 2. So what I'm saying is that y of t is actually x of 2t and z of t is x of t by 2. How so? Here's how. So, I mean, following up on what Hassan says on the chat box as well. So the value that y takes at time t is the value that x takes at time 2t. So in other words, the value that y is going to take at time 1 is the value that x takes at time 2. Okay, which is exactly actually what Hassan says as well. I mean, is this clear? I mean, go back. Manur, जिन्होंने दूसरे आंसर दिए थे. Manu, can you unmute yourself and talk to me? I mean, let's have a,
yes, sir. It's clear. अब समझ आ
now?
गई.
Okay.
Yes.
Anyone else who had the same confusion? Let me say this again. I mean, और किसने बोला था ये वाली?
मुझे समझ नहीं आई सर, लाइक जो काम भानु ने इससे पहले बात की थी कि वो जो सर ये ऑपोजिट होना चाहिए सर, लाइक उसका 2t होना चाहिए, उसका t/2 होना चाहिए.
क्यों होना चाहिए ना? आप ये बताएं मुझे पहले. So I'm saying कि this is how I can refute this answer, which is that the value that y takes at time t is the value that x takes at time 2t. So therefore, if I plug in some values of y, so therefore, if I compute what y of 1 is, then what should that be as a function of x?
Y of 1.
Then y of 1 is what x के terms में क्या होगा?
सर वो x के terms में
x of 2,
x of 2, right? Right?
Yes, sir.
So you just plug in t equals 1. Right? So you just plug in t equals 1, and on both sides, so y of 1 is actually equal to x of 2. इसका मतलब, similarly, what is y of half? Y of half is x of 1. And does this mean compression? That of course means compression. Right? And similarly, you can do it for the z as well. What is z of 2? That z of 2 is actually equal to x of 1. And similarly, z of 4 is x of 2. Right? And therefore, z is an expanded version of x, and y is a compressed version of x because of this mathematical description. ठीक है? जी तलहा?
Sorry, पहले से करा था.
Oh, that's fine. Okay. Any questions here before we move on and do some interesting example, or perhaps a little bit more involved example than this? All right, no questions? All right, so let's do an example. Okay, let me see if I have an, all right. So here's an exercise for you now. So you're given a signal x, and this is what it looks like. So this is x of t. This is the time axis on the x-axis, and the signal is what we had earlier, a little bit before this. This is this. Acha, sorry, I forgot the question that Musa raised. Right, so this compression and this expansion is on the time axis, and he asked here, is this on the vertical axis as well? And of course, this is not on the vertical axis. Why? Because Musa, the value that y takes at time t equals 1 is exactly what the value that x takes at time t equals 2. I mean, there's no scaling in the amplitude. Is that clear? If
Yes,
you
sir.
were to do that scaling in amplitude, I mean, mathematically, किस तरह करेंगे?
Sir, 2 of yt is equal to xt, x of t.
Excellent, right? Or y of t equals 2 times x of t. That means
जी,
कि
जी.
x को मैं amplitude में scaling कर रहा हूँ.
Right.
Right, and that's like an amplifier. I mean, you put this through an
Okay.
amplifier, okay, or a gain.
Sir, तो वो time scaling में नहीं होती है, मतलब होती ही नहीं है signal
नहीं, वो होती है, बिल्कुल होती है. But that operation is because it's much simpler. I mean, we do not explicitly talk about this here. I mean, that's just a multiply. Or another way to put this is, KG, the transformations that we're talking about in this section are transformations on the time axis.
Okay.
Okay? That's what we're doing. Right.
Thank you, sir.
Right. So here's an exercise. This is x of t, which is this signal. Right. So this is 0. This is 1, and this is 2. Apologies if it's not to scale, but that's fine. And we are required. So what I tell you is, Kiar, sketch y of t equals x of 2t plus 1. Right? And clearly, y is a signal that not only involves, I mean, it involves two operations. What are those operations? Those operations are scaling on the time axis and shifting on the time axis. Right? The question is, KG, how do we do it? I mean, what do we do first? I mean, do we do the scaling first, or do we do the shifting first? Right? It turns out it doesn't really matter. I mean, you can do either one. You can do either one. Okay? And let's do it both ways. I mean, let's do shifting first and then scaling. And then we're going to do it another way, which is scaling first and then shifting. Okay? So here's two methods. And of course, I mean, if the methods are correct, I mean, both methods are correct, they should yield the same result, right? If they don't yield the same result, iska matlab, I mean, we've done something wrong somewhere. Okay? All right. So somebody said, Azmir, for example, said, do the shifting first. Okay, let's do that, right? So what do you mean by shifting first, Azmir?
So we advance the signal by 1 and then we scale it.
Okay. So let me therefore define an intermediate signal z of t, which is just a shifted version of x of t. Okay? So this is an intermediate signal x, intermediate signal z. Okay? What would z look like if I were to sketch z? This is what it would be, right? So
left. Starting with -1, ending at 1.
All right, to my left. Okay, good. Right, so this is goes like this, goes like this. Goes like this, this, and this, and this, and this stays here, right? So what is so Munim, ये वाला axis यहाँ पे क्या होगा? Leftmost.
Sir, -1.
-1, and then this is 0, and this is +1. Okay? Right. So Munim, I'm going to come to your comment as well. I mean, it turns out that you can do either one of those first. Right? So this is, this is z of t.
But sir, mathematically, if we're solving the terms inside the brackets, wouldn't we like multiply first before adding?
Doesn't matter. Doesn't matter. I mean,
Doesn't
you
matter?
can do
Okay.
you can do either one as long as you make sure that the operations that you do result in the signal that you want.
All right. All right.
Okay. So I mean, I think you're confused by शायद वो जो board mass वाली चीज में उस तरफ तो नहीं जा रहे कहीं आप कि you do the multiplication first and then the addition.
It seemed right.
Yeah.
So इसलिए मैंने कहा.
But let me go through this and then hopefully it's going to come clearer. Okay. So z of t is x of t plus 1. Now here's the question. The question is, what do I do with, how do I scale z, or what operation, what transformation do I apply to z for me to get the signal which is desired, which is y. Okay. So in other words, if I want to write y as a function of z, what would that function be? And I claim that that is equal to z of 2t. Why? Because if I plug in this 2t into this t here, असल में क्या होगा, this t would become 2t as well. Right? So therefore, I can say that this is actually equal to x of 2t plus 1, because all I've done is I've just replaced the independent variable t with an independent variable 2t. No, it won't be 2t plus 2. Right? Because the independent variable is t. 1 is not an independent variable. वो तो वहाँ पे constant है. Right? So the way I think about this is that, I mean, this is a function, right? It's a function of t. If it's a function of t, so, and if you say t की जगह मैं v डाल दूँ, तो all you do on the right hand side is just replace t with v. Okay, Hasan? Right? If on the left hand side, instead of t, I just replace it by 2t, the right hand side पे 2t की जगह 2t डाल दें. Right? Does that make sense? Okay. Right. So therefore, if I compress now this intermediate signal z by a factor of 2, I will get the desired signal y, which was actually equal to x of 2t plus 1. Okay. And the way I verify this is through this mathematical substitution. Okay. So mathematical reasoning. And therefore, this is what y is going to look like. So this is t. This is y of t. And what would y of t be? Y of t would just simply be a compressed version of z, right? And therefore, this is what you're going to have. And this starts at minus half. It ends at plus half. Okay, so this is y of t. Okay, let's do it the other way. Jo Ammonium suggested, right? Which was, okay, let's define an intermediate signal which does the scaling first, the time scaling first. So for that, let me use w of t as an intermediate signal. And I say, let w of t be x of 2t. Right? What would x of 2t be, or what would w of t be? So this is time t, okay? And this is w of t. W of t is a compressed version of x. Okay, so this is what it looks like. यहाँ पे जाता है, and then, right? And here this is half, and this is 1. Okay, does that make sense? So w is just a compressed version of x. Now here's my question. What do you do with w for you to be able to get y? Right, there's somebody who raised their hand here. फिर नीचे कर दिया है. Khanzada something. Was that?
सर मुझे पूछना था कि आपका जो ग्राफ बना हुआ है पहले वाले एग्जाम मेथड पे माइनस हाफ एंड हाफ पे, उस पे आपने कोई y एक्सिस पे तो स्केलिंग नहीं की ना?
No, वो नहीं की. Right.
वो नहीं, क्योंकि ग्राफ कंपैरेटिवली छोटा था तो मैं थोड़ा कंफ्यूज हो
गया. Thank you for pointing this out. I just want to make clear that there's no scaling on the vertical axis. If this is 1, this stays 1, and this is 1 as well.
Okay, sir. Thank you.
Thank you. Thank you for pointing that out. Okay. Now, all right, so there are two answers here, which is kg y of t equals wt plus 1. A couple of people give that answer. There's one person who say y of t equals w t plus 0.5. Okay, so let me talk to, and Minahil also says t plus half. Hassan says, okay, yes, he understands now. Right, so it's very, very nice. I mean, I'm very, very happy by this interaction, even though it's on the chat window. But who had the other answer? Hassan Shabir had WT plus 1. So I'm going to pick on you, Hassan. Hassan Shabir. Right, so.
Yes, sir.
Right, so why do you say W of t plus 1?
Sir, like the same concept you told for the method 1, जिसमें you said कि 1 तो एक वैसी constant है.
Okay, but here's you see, 2 is being multiplied by t. So here's what I do. Let's just check what you're saying. What you're saying is W of t plus 1, right?
Yes.
Okay. So what would W of t plus 1 be? That would be, you just plug in t plus 1 here, right? Because यहाँ पे t था, आपने इस right side पे t की जगह बस t plus 1 डाल देना, right? And therefore this would be x of 2, and then you have inside the brackets t plus 1.
Yes, sir, got it now.
Got it? Right? So therefore this would be x of 2t plus 2, but this is not what you were looking for.
Yeah.
Right? So therefore this is actually not equal to y of t that you were looking for. In order for you to get y of t, what would you do, Hassan? क्या होना चाहिए?
Sir, हम t plus 1 by 2 put करेंगे तो फिर we'll get.
Zabardast. Really, really happy, right? So, so this would be, I'd say y of t is actually equal to w of t plus half, because this is, so let me put it another way. And I say, Kiji, let me just try what w of t plus half is, and this is equal to x of 2 times t plus half, and this is x of 2t plus 1, which is what I was looking for, which is equal to y of t indeed. And therefore, if I were to plot this y of t now, what would that y of t be? Y of t would be a shifted version of w, which is y of t is w of t plus half. So I'm going to take w of t from here, ये वाला जो w पड़ा हुआ है, right? और इसको मैंने shift क्या करना है? I want to shift it by half to the left because it's plus half, because it's advanced by half a second, right? And the result that I'm going to get is the following. So this is minus half, and this is plus half, and the height, of course, stays 1. And you get the same result for both cases. You get both methods, you get the same result. Right? So my point here is, it doesn't really matter whether you do the shifting first or the scaling first. Right? All you need to make sure is if you're doing the shifting first and then scaling, you do it in the right way so that you get to what you're desired. Right? Similarly, if you're doing the scaling first, then the shifting has to be scaled as well. Right? So that's all you need to be careful about. Right? And I can play around with this so much. So, I mean, I can put in a minus sign there and just say, what is x of minus t plus 1? And then I ask you, do you do the reversal first or you do the shifting first? The answer is, I mean, do anything you want. Right? पहले reversal कर लें, तो आपको shifting कहीं और करनी पड़ेगी. पहले shifting कर लें, तो फिर किसी और तरफ करनी पड़ेगी, reversal करना पड़ेगा. ठीक है? So you just have to be consistent with what you want. Okay? Any questions here? And we're going to assign more examples in the homework so that this concept is solidified. Okay? Any questions here? Okay, no questions. Right. So let me briefly talk about some categories of signal which are called so even signals and odd signals. So anybody heard of these signals before this? Even signals क्या होते हैं, odd signals क्या होते हैं? No? Yes, Abdullah. Okay. Abdullah, कहाँ पे सुना आपने even signals के बारे में, odd signals के बारे में?
कैलकुलस में.
जी, sorry, किधर? Calculus में. Okay.
कैलकुलस में.
Right. So a signal is even. Hasan, बताइएगा, when is it even?
Sir, when x of t is equal to x of minus t.
Right. When x of t equals x of minus t. Okay. So here's what about odd?
That would be x of t is equal to minus x of t.
Is odd when x of t. So this is familiar concepts. Looks like is minus x of minus t. Okay. And by the way, there's an implication of this thing here. When a signal is odd, what does that mean? What would the signal be at time t equals 0?
Should be 0, sir.
Should be 0. Why?
Because that's the only number that's also its own negative.
Excellent. Does everyone else get the point? So odd signals must satisfy the following condition, that x of 0 is equal to 0. Okay. Does everybody see that? So I'm gonna pick on people who have not spoken yet. Okay, so I'm randomly gonna pick somebody. कौन को? Ibrahim, नहीं Ibrahim ने बोला. Daniel. Daniel, what do you think? I mean, why is this true? Why is x of 0 equals 0? Daniel.
Ji sir.
So why do you think that x of 0 equals 0 for odd signals?
सर क्योंकि 0 का नेगेटिव मतलब 0 से माइनस से मल्टीप्लाई करें तो वो भी 0 ही होता है.
Okay, right. So that's true. Good. Right. So the only number which is a negative of itself is 0. Right. So because x of t equals minus of x of minus t, if I plug in t equals 0, therefore x of 0 must be equal to minus x of 0, and the only number that satisfies this is 0. Right. So this is a fact that for any odd signal, x of 0 must be equal to 0. Let me give you some examples or some sketches of an odd signal and an even.
Sir?
जी.
Sir, अगर ये odd signal के लिए true है तो ये even के लिए भी तो true होना चाहिए because like एक minus sign ही बाहर add होगा ना तो
नहीं. Well, you see, so आपको ये क्या बताता है? So this tells you that if I plug in t equals 0, that tells you that x of 0 equals x of 0. Right? Is this enough for you to conclude that x of 0 equals 0?
तो सर फिर odd signals के लिए कैसे ये आप confirm करते हैं कि हमेशा x of 0 0 होगा?
For odd signals, this is x of 0 equals minus x of 0.
But sir, that minus sign can't actually, मतलब अगर अंदर x of 0 में 0 आ गया है, so it doesn't really matter कि sir, because sir, if you say कि x of 0 is equal to minus x of 0, you should also say कि x of 0 is equal to x of 0 because like a minus sign can't actually change a real number to 0 ना. So
it can. So if I say can 2 be equal to minus 2?
Yeah.
Right, so this is an equation that you're solving. Okay, this is an equation that you're solving. If you say x of 0 equals minus x of 0, that means this is 2 times x of 0 equals 0. What is the solution to that equation?
Sorry.
Okay, that solution is 0. But on the other hand, if I say x equals x, what is the solution to that equation? I mean, you can't solve it.
Yes, sir.
Right? It could be anything. But on the other hand, x equals minus x, the solution to that is 0. Okay? All right.
Yes, sir.
And I can give you examples here. So let's just do a counter example, right? Or an example. So this is, for example, an odd signal. Right? So I use blue. Right. So this is the time axis. This is some signal x of t. And let's say this is what the signal looks like. So it's symmetric around the y-axis. So therefore, x of t equals minus x of t. X of t equals x of minus t. Okay? And it's clearly at time t equals 0, it's not equal to 0. And this is still an even signal. Okay? And there were examples of even signals that I showed up above as well. जिसमें मैंने कहा था कि इसका time reversal क्या होगा, and some people said it would be exactly the same thing, and that signal was also an even signal. On the other hand, an odd signal, I mean, of course, there could be many examples. This is just one illustration. And this is an odd signal. You can stay 0 afterwards. Okay. Right, so this is x of t. This signal is odd. And this signal is even. Okay, Ji Musa.
So I just wanted to ask that can a signal be like neither या उसको एक होना पड़ता दोनों में से?
What do you think?
So I was thinking that maybe it could be neither as well, because maybe it's not specifying, I mean, filling in any condition.
Okay, can you give me so again, when somebody says KG, isko show that there's a signal, there can exist signals which are neither odd signals or even signals. How do you prove that? You just provide an example which satisfies that condition, right?
Right.
Can you give me an example of something?
So sir, for example, there's a function where x of 2 is 3 and x of minus 2 is like minus 5.
Yeah.
So it's
Zabardast, right?
Oh,
And,
okay.
Right, and so just with regards to your comment, right? So
yeah.
Let me. This signal is neither even nor odd.
Oh, okay.
Okay. I'm similar to, I think somebody, Hassan says step function. So this is sort of a step function.
So yeah. So thank you, sir.
Okay. So this is neither even nor odd.
See.
Okay. Any other questions? Okay. Ji Talha.
So if a signal is not symmetrical, it's going to be it's going to be neither even nor odd. Like in a way, the odd signal is also symmetrical.
So you use the term symmetric, right? So I mean, we just want to, iska matlab kya hai? Symmetric is so if the signal is symmetric, so you say that this signal in
I just realized that that's going to be a problem.
So this signal is symmetric, and symmetry is perhaps another name of saying that signals are even. Okay?
ठीक है.
और ये जो odd signal है, इसको हम typically क्या कहते हैं? Anti-symmetric.
Okay, yeah.
Right, so these are typically referred to as anti-symmetric, even though, I mean, that's not a term that we're going to use as far as signals language is concerned. As far as signals language is concerned, this anti-symmetry that you may have been familiar with is now going to be called an odd signal. Similarly, symmetric signals are going to be called even signals. And there may be signals, of course, which are neither symmetric nor anti-symmetric, and therefore those signals are neither even signals nor odd signals. Okay? So I see several hands raised. Musa, आपका हाथ अभी खड़ा है या पहले का है? Right, Talha.
Sir, Pranata.
Tala, please go ahead.
Sir, I just asked you the question.
Oh, you did? Achha.
Yeah.
Oh, sorry. Azmir?
I just wanted to ask that we can convert, between even, odd, and neither even or odd using the transformation properties, right?
What do you mean by that, Azmir? थोड़ा सा उसको explain करें.
For example, जिस तरह अभी आपने एक जो neither even nor odd function बनाया था, अगर हम उसको time advance कर देते हैं तो वो एक even function बन जाएगा.
बन जाएगा.
So we can achieve that. सही है.
Just by transformation, for this particular case, yes.
ठीक है.
For this particular case, yes, but not for all cases.
Yeah, but in some, I meant to ask in some cases.
In some cases, yes. हाँ जी. Okay, Masna?
Sir, I wanted to ask that the odd signal, you said for an even signal x0 is equal to x0. So isn't that true for the odd signal too, because it's 0 at both?
So for even signals, I would just say that if you plug in t equals 0, what I get is all I know is that x of 0 must be equal to x of 0. Does that tell me anything about what x of 0 is?
No, sir. लेकिन ये जो odd signal आपने बनाया है, इसके अंदर x of 0 is 0.
0. And for odd signals, this must be satisfied. Why? Because if a signal is odd, that means x of t must be equal to minus x of minus t. And if I plug in t equals 0 in this expression, what do I get? I get x of 0 must be equal to minus x of 0.
Yes.
Right? What is the only signal that satisfies that property? Or what is the only number that satisfies that property? What is the only
0.
number that is equal to the negative of itself? 0. Okay?
No, sir. What I meant was that this is an odd signal, but can't this be considered an even signal too, because it's 0?
Why can it be considered an even signal? I mean, this does not satisfy the symmetry property. I mean, x of t is not equal to x of minus t. Is it?
Yes. Okay. Thank you.
Okay. G. Azmir.